Okay, so line 1 has equation all this business, and line 2 has equation all of this junk. Show that L1 and L2 do not meet. Okay, so you can kind of get an intuition for this without actually proving anything. So let's say we have y-axis there and the x-axis here and the z-axis here. Alright, so let's say we do L1 in green. So r equals 1, 0, negative 1. So this is going to be kind of like 1 on the x-axis here, 0 on the y-axis, and then negative 1 on the z-axis. So it's going to kind of start somewhere around there, say. And so it's going to go 1 in the x direction, and then 1 in the y direction. So we're going to end up with a line that's scaling by lambda up and down like that. So if we do the same thing for L2, so it's going to start 1 on the x-axis, and this time we're going to go 1, 2, 3 roughly on the y-axis, and then 6 on the z-axis. So let's just say that's somewhere around there, so and then all the way over here, let's just say that's there somewhere. Okay, and then so every 2 in the x direction it goes, it's going to go 1 in the y direction, and it's going to go 1 up here, and it's going to go 1 back in the z direction. So this guy is going to look something like that. He's going off in that direction and back that way. And so it's not easy to draw in 3D space, but hopefully you guys can see that these lines are not going to meet. Okay, so how do we prove that they're not going to meet? So if L1 and L2 meet, okay, then we should be able to find a lambda, okay, a direction that you can travel in on this line to get to, and mu, the direction you're going to be able to travel along on this line, where these guys meet. So how do we show that we don't? So let's just take the equation for L1. 1, 0, negative 1, right? Plus lambda times 1, 1, 0. And let's set that equal to this equation here, which is 1, 3, 6 plus mu times 2, 1, and negative 1. Mu. Okay, so this gives us 3 equations. Equation 1 is 1 plus lambda equals 1 plus 2 mu. So that's 1 plus 1 lambda equals 1 plus 2 mu. Equation 2, we have 0 plus 1 lambda, so lambda equals 3 plus 1 mu, so just mu. And then equation 3, we've got -1 plus 0 lambda equals 6 minus mu. Alright, so equation 3 is kind of a little bit of a gift here. So let's just move mu over here and then add 1 to both sides. So we have mu from equation 3, we have mu equals 7. Okay. So let's plug that into both of these equations. So we plug mu equals 7 into equation 1, right? Plug that into equation 1. Then that gives us 1 plus lambda equals 1 plus 2 times 7, which is 1 plus 14. Obviously the 1's cancel out, so lambda equals 14. If we do the same thing for equation 2, plug in mu equals 7. Okay, we get lambda equals 3 plus 7, which is 10. Now, of course, 10 does not equal 14. And so I guess it's pretty obvious that it follows that that L1 and L2 do not meet. Right, so therefore L1 and L2 do not meet. But we can confirm this. Let's say we take 10, okay, and plug this into lambda equals 10, right? And plug this into equation 1. Then that's going to give us a value for mu of 5, right? So 1 plus 10 equals 11, plus 1, take that 1 from there, that's going to give us 10. 10 divided by 2 equals 5, and obviously we can see that 5 does not equal 7. So there you have it. L1 and L2 do not meet.